Hi, my name is Sharon Guo,
Hi, my name is Yutong,
and this is our Lab 2 demo for EE542. So I'm going to begin with checking to make sure that I am on an Ethernet connection. And now I'm going to ping Yutong's computer. And I'm just going to make sure that I don't have any delays. Alright, so speed is quite fast, and now I'm going to add a 10 millisecond delay. Alright, so now when I ping Yutong's computer, I should get an additional 10 minutes in my round trip time. And yep, that result is as it should be. So let me check what my Ethernet speed is right now. So right now it's set to 100 megabits per second. So now I'm going to change that to 1 gigabyte per second. And now I'm going to recheck my connection speed. And yes, so it was correctly changed to 1 gigabyte per second. And now I'm going to remove the delay that I just added so that we can do iPerf measurements with 0 delay. Alright, so first we're going to run iPerf for UDP. So Yutong is going to serve as the server and my computer will be the client. So it looks like our UDP bandwidth is 918 megabits per second, which is pretty high as expected. So now we're going to do iPerf again, but over TCP this time. Alright, so it looks like our throughput for TCP is 922 megabits per second. So it's not quite 1 gigabyte, but it's very close.
Hi, now I'll be talking about our helper script that we wrote for this lab. It's called Auto iPerf, and what it does is it automatically uses the iPerf client command to connect to our server multiple times using different delays at different for each iteration. And so Auto iPerf does just that, and we create another script called Auto iPerf 2, which also lets us set the window size when we call the iPerf command. But for now, I'll show you guys Auto iPerf in action. So we'll just go ahead and type in our command here. We'll provide it with the IP address 192.168.5.148, and we should use sudo for the privileges. Alright. So it just got its first measurement at delay of 0. And we'll just let that run for a bit. Okay, so after leaving it running for a bit, we see that we've gotten data for delay of 0 milliseconds, add delay of 10 milliseconds, 100 milliseconds, 200, and now we're doing 500 milliseconds. And as you can expect, the average speed is going down as we increase the delay. Start off at 900 megabytes per second, and we ended with about 72 megabytes. Yeah, 72 megabytes per second. And so that is our auto iPerf shell script that we've been using, and we'll demonstrate its use later on in this lab as well.
Alright, and now I'm going to be showing changing window size and the effects of changing window size when we run iPerf. So first, let's see what the current window size is. So currently it's 212.992. So now I'm going to change it to 2 megabytes. So I'm going to be changing both our memmax and WMemmax to 209.7152. Alright, and now we're just going to run the script again. So now it's running. And it's going to take a while again, so we'll pause and resume once we get closer to the end of the script. Alright, so as you can see, the script has finished running, and when we compare the results to the previous ones that we obtained, there's basically no change. But just to further demonstrate that, we're going to set the max even larger. So now we're just going to add a 0 to the end. So it's 20 megabytes. And Yutong is changing his window size to be the exact same as mine so that our computers are matching. Now I'm just going to run the script again. Alright, so the script is finished running, and again you can see that there's really almost no real change in the numbers, which is surprising considering we multiply it by a factor of 10. So what we're going to do now is actually change the window size in iPerf. So I'm going to be running the previously mentioned auto iPerf 2 script, which takes in a window size argument. So I'm going to give it a very large window just to see a change. So right now all the simulations we've been doing has been running on default iPerf window size. So now we're going to give it a really big window size. So I'm going to run it at 2 megabytes of window space, but an interesting thing to know is that I'm writing in 1M, and that's because Linux automatically scales that times 2. So now that I'm running it, it's really running at 2 megabytes. And Yutong has scaled his server side to match my client window size. So again, I'm just going to let the script run through. Alright, and now our script has finished running. So now that we have a baseline of a very high window size to compare, we're going to do a really small window size now. So in order to get a super small window size, we're just going to put some arbitrary super small number, like just 10 here. And that number is too small for iPerf to actually run, so instead it's going to run the minimum. And actually, I didn't demonstrate this before, but you can't see the window size when I run the script, so I'm just going to run it once so that you can actually see the window size has changed. So do window 10. Yeah, you can see right now the window size is 4.5 kilobytes because our requested 10 bytes was too small. And I'm just going to, again, verify that when I put 1M here, it's really going to be running with a 2 megabyte window size. And yeah, so that's just showing that explicitly. So now I'm going to go back to our very small minimum window size, and I'm going to be running the script again. So you see, even though it'll give the warning that it's too small, but it's really running at 4.5 kilobyte window as previously shown. So I'm going to pause until the script has finished running and then return. Alright, so you can see our script has finished running, and if you look at the numbers, for instance, so originally we were getting around over 900, but now we're getting around 42 megabits instead of 900 megabits per second. So overall, our numbers are just much smaller. And so this is just demonstrating that we can change the TCP window size for actual data. We use a lot of data points, and so we found the trend was that as the window went down, so did our throughput. We're now going to talk about simulating packet loss. So we're going to use this command, sudo tc qdisk add dev your Ethernet name, so that's my Ethernet name, root netum loss, and we're going to be simulating 5% loss. So the way we're going to demonstrate this is Yutong is actually going to be putting this command in on his side, and I'm going to be acting as an iPerf UDP server, and so he's going to be its client, and it should show that we have a 5% packet loss. So I'm going to start the iPerf UDP server. Alright, so I've started the server, and Yutong is connected. Yeah, as you can see, under the lost total datagrams, it shows 5.6% loss. And now we're just going to demonstrate that normally it doesn't show that, so we're going to remove the packet loss. And send it again. So as you can see now, it shows 0.49% packet loss. So this 5.6 is because we set that artificial packet loss to be 5%.
Hi, now I'll be talking about the SCP command, which we'll be using to transfer files through our link from my computer to Sharon's computer. Now SCP stands for Secure Copy, which uses the Secure Shell Host Protocol, SSH, in order to transfer files from my computer to Sharon's. And firstly, to get this get our setup going, is we have to mount a partition onto the mount file system, and I'll just show here. This is where we'll be mounting it. Right now, there's nothing in there. If I do ls, nothing pops up. Let's clear that. Now, we didn't have the command make extra fs, so we had to do it manually, and we had to use gparted to create a partition on our hard disk, which you can see by doing ls block, that we created an extra partition in our hard drive that was about 500 megabytes. So with that, we just mount it onto our mount file. So let's do that. So the command is sudo mount dev nvme0n1p6, which corresponds to the name of the partition that we want, and we want to mount it to MNT. So now if we go to MNT, we'll see that there is now data in there, and let's just show how we created our data.bin file. It was done so by using dd if equals dev urandom, so that's the input file. The output file is going to be data.bin, and the block size is going to be 1 megabytes, and there's going to be 200 of those, so it's going to be a total of 200 megabytes in size. And basically what that does is it copies 200 megabytes of random data into our data.bin. So if I do that, it might take a while. But here we go. There's our data.bin. Okay, so once we have that, we can send our data.bin over to Sharon by using scp sudo scp data.bin Sharon, which is her username, at, and then her IP address, :/ and then the file where we want it. So once we have that, this is important to note, but Sharon also has to mount the drive into a partition into her mount folder in order for this command to work properly, in order for us to be able to send the data to her mount drive. So hit that, enter in the password, and that shows us the transfer speed. We were able to get 98.4 megabytes per second on our 1 gigabyte link, gigabits per second link. So we were able to transfer 200 megabytes in 2 seconds to Sharon for a total of 98.4 megabytes per second. So that is our demonstration of SCP, and we'll be using that to determine throughput and the effects of network conditions on it in the next part of this video. Alright, so for these tests, we'll first be going and sending a file at 100 megabytes per second to Sharon. We'll be first varying the delay, then we will be varying the window size, and lastly we'll be varying the loss, and we'll be looking at the throughput generated at the end of our SCP command as feedback for what our throughput was. So first off, let's change our Ethernet speed to 100. And so once we've done that, then we can set the delay. So let's set the delay to, well, first let's get a baseline here. Let's send the data over to Sharon and see what our baseline is. So at 10 megabytes per second. Okay, so it says our ETA is about to be around 30 seconds, so we'll let that run for a little bit, and we'll be back shortly. Okay, so we let that file transfer run to completion, and we got about 5.66 megabytes per second, which is pretty good, but not as fast as what we had before with 1,000 megabytes per second. But now we will focus on our delay. So just to check up on our delay before, we'll just ping Sharon, and it says we have about 0.4 milliseconds of delay, which is good, which indicates to us that we didn't add any additional delay. So now we'll add 10 milliseconds, and we'll see what we get in terms of our throughput. Now we'll well, let's check our ping again. So yeah, now we at 10.4 milliseconds of round trip time. Right. And we will now transfer to Sharon. So right off the bat, you can kind of see that the throughput's a little bit lower, already less than half of the throughput at 0 delay. So, and our ETA is about 1 minute 30 seconds before it completes. So we'll let that run, and then we will take a look at what the final value comes out to be. Alright, so we have completed our test, and right here it tells us that our speed was 1.5 megabytes per second, and it completed in about 2 minutes and 17 seconds. This is significantly less than what we had before, which was 5.6 megabytes per second when we didn't have a delay. So it goes to show that adding delay does reduce the throughput of your system to a degree. Now we want to take a look at changing our memory size, changing our window size in order to improve our performance. So let's start with a fresh screen. So let's just check to see. Let's first get rid of our delay, so that way we can get back to 33 or 5.6 megabytes per second speed. So we'll just run. Right. Okay. So oh, we already deleted it. So right now let's just check that speed with ping. Alright, so we have a time of, yep, so that we don't have that 10 millisecond delay anymore. So we can try to see if we can do any better than our original 5.6 megabytes per second. So what we were doing before with RMEM was we were setting the RMEM max so that way our buffer size doesn't overflow when we try to send bigger windows. So we'll just keep it at 2 megabytes for now. So we just set it. And now we just need to increase our TCP window size. So the command for that is to first echo. Oh, that's not it. Okay, so in order to first we want to take a look at what the current window size is set to for TCP. So actually we have that pulled up here. So if you look into the file proc sysnet IPv4 TCP RMEM, you'll get 3 numbers, and these 3 numbers represent the minimum window size, the default window size, and the maximum window size. Before, when we were using iperf, we could specify the window size we needed by using the -w command, that parameter. But if we wanted to modify it on the kernel, we would have to modify it using modify these files. So the way we do that is we can't modify it directly. We need to modify the syscontrol conf file, which specifies which will specify the default window size and all that to the kernel when we restart the syscontrol. All right. So in order to do that, we will have to modify syscontrol.conf here. Oh, that's not the right file. It's sysctl.conf. So right here we've already modified it. So we'll just show what we have here. We've set the RMEM to minimum of about 10,000, the default to about 873,000, and the max to the 2 mega. This is actually 20 megabytes window. So let's just change it so it's a little bit bigger. Just add let's see, let's change this to a 10, and let's see if we get any improvements in speed. Alright, so let's do that, and we just have to restart sysctl, and it should now change the TCP WMEM to the new values. So yep, you can see here we have increased the default window size. So hopefully that should have an effect on our transfer speed. So let's go do SCP again, and we will see what our final results will be. Okay, so the command finished, and turns out we actually had a decrease in performance slightly as a result of changing our syscontrol. But just to test out, let's try increasing our default a little bit more, just to verify that. So we'll just be changing our default to 12 megabytes now, or that's not 12, that's 1.2 megabytes. Okay, so we will restart syscontrol and we'll transfer again. Okay, so after completion it showed that the throughput actually went down some more. But anyways, now we move on to our final test, which is the effect on loss as we change the loss, as we add loss to the network. So before we begin, let's set our window back to what it was before. So default was 8, and let's restart syscontrol and let's just kind of validate it. Okay, so we'll be using 4.8 as our baseline for this, and so now we will add loss to our network by using the tcqdisk command we were using before, and we'll just add a loss of 5% for this one, and now we will transfer to Sharon. And let's check back in on what the final result will be. Alright, so after that it showed that our final throughput was 1 megabytes per second, which as expected is much less than what we would have gotten if we were in a lossless system. So that concludes our demonstration for SCP. Yeah. And that also concludes the rest of our demo as well. Hope this was informative, and we wish you a good rest of your day.